Thank you, sir. Thank you, sir. Now I request Professor Swain to please come up on the podium and start the session with his opening remarks.
Good afternoon, everybody, and my fellow panelists, Professor Suneel, Saraswat, and Arbind. Okay, yeah. So, looking at the audience, it seems that there is not much interest in econometrics area in this ML and AI, which is growing like anything in the business domain. So, just I will a little bit highlight because Professor Suneel Saraswat will explain you ML in detail. If you look at so far the title is concerned the predictive power of artificial intelligence and machine learning. When you require to predict, basically it comes into picture when there will be uncertainty. Uncertainty means there will be something that you cannot easily understand the behavior of the system. When it comes into that, there it comes, the things that is easily predictable, means it is easy to understand, is the ordered system. Basically, linear regression and so that you talk about, the complexity is very, very less. It is a very simple system. So in that ordered system, where the structural understanding also low, that type of system is basically used in econometrics and economics a lot because of its understandability, interpretability. Interpretability plays important role in econometrics, and so also the theory part. But when you are coming to the data, when the data are down to you, like what you are going to address in the ML and AI subsequently, Professor Saraswat will introduce that, and Shri Arbind also will be demonstrating that. There you will see, when you get into more complex things, like where it is very difficult to understand the systems, particularly neural network and so, which are more complex, or some kind of complex type of, say, maybe polynomial type of, higher order polynomial type of regressor, linear regressor, where interpretability is much less. So those type of systems when you are going to use to model the data, and where difficult to get the theory, because either the theory doesn't exist or you do not have the time to work on to reach to the theory part, particularly the causality part, which is very, very important in econometrics domain, because you have to explain that. So far as the regulatory requirements are concerned, or to in the management open to the customers, why you have rejected some loan applications or so. So you need to explain it. So the explainability plays important role in the econometrics as well as in the machine learning and AI. Special field like explainable AI and the explainable ML plays the important role now. So how to explain the things, that is the important aspect of this econometrics area also. And if you look at, get into the complexity, when you are looking at this model complexity and you are getting into the neural network and so, laden with much more uncertainty, then it will be very, very difficult to basically see or to verify the outcome whether it is going to be useful or not. So these are the certain crucial issues that in future need to be finalized by the business community basically. If you look at in other way, machine learning practically being used for the predictive part when it is helping or supporting the decision maker to arrive at some kind of decision. But the major important part of the decision making, which is not at address, which possibly in future will get the answers, how the causality is going to, that is basically causality is the base for our intuitive judgment things that we are taking, where AI plays an important role. Because the judgment area, when the human beings are good at, so there, how the AI will come into and automate that part, so that decision maker will be free to do some higher level of job and so. So that is what the future research is coming up, and basically how this causality. Through the causality, we will try to understand how our intuitive understanding is being shaped over the period of time. So these are basically some of the issues. Possibly our Professor Suneel and Shri Arbind will be highlighting and demonstrating the things here. So thank you very much for your presence here. And now I will request Professor Suneel Saraswat to deliver his talk.
Welcome all. I thank the organizer for inviting all of us for this beautiful campus and also being part of this conference. And talk about, so the main idea is that AI/ML these days is so popular that we should all be able to use it with a little bit of understanding. It can be easily used as a tool. So the purpose of this presentation is to give you some background about the AI/ML development, some history, and some popular things, some popular terminology, some key terms which are important to know. And then at the end, some small demos so that you can be confident that even without knowing, computer programming or these complex maths behind machine learning, you can still use it as a tool like you are using already tools like Excel and other tools. So that's the main idea of this system. So I'll start with some basic history of AI/ML. So what is machine learning? So in traditional learning models, we give very specific instructions to computer, and then the computer performs those instructions naturally. In machine learning, in AI, we do not give very specific instructions to the computer. We just make the computer programs learn, the algorithms learn the computer program which can make predictions from the data. So that is the key idea. So you basically, in short, it's a learning system where we have input data and we expect the correct output. And your input can be a single number, and output can also be a single number. Your input can be a single number, output can be vector. Your input can be a vector, output can be a single number, or your input, output both can be. So it works in all. So this ML can take all this form, one to one, one to many, many to one, many to many. That is the essence. So that's why it can be generalized for any kind of input data or any kind of output data. So to look at some history of ML, the first model of neural network model, which is one of the most key model used these days in AI. The idea was inspired by the human neurons, so neurons in our body. So the first model that is known as neuron model was given by McCullough and Pitts in 1943. So the basic idea is that each for a given input x1 to xn, a neuron, basically these are the binary inputs. Okay, you can think of it like they are, the sensors, and the function f is applied on these inputs. And so the first we apply the function z, which is, let's say, the sum of these inputs, and then a decision function f is applied to take the final decision. It's a very simple model. There are several limitations. All the inputs are binary. That is one important limitation. And the second is that there is no learning here. So the only learning is that you have to learn the correct function f. That was the first model. Later, this model was improved by Frank Rosenblatt. Okay. So he gave a more slightly more general model where weights, there can be weights for the input. So your entire neuron model can be that given input x1 to xn, we have a weights associated with respect to each of these inputs, that is w1 to wn, and then we take the linear combinations, that is x1 w1 plus x2 w2 and so on, and you can think of x4 as a bias, and then we apply a state function. Okay. If this sum is beyond the threshold, the output is 1, otherwise 0. So this is a very simple model. But again, it is slightly more generalized than the previous model, but this also has some limitations. And the model was talked about Minsky in 1969 as a perceptron model, and he also showed that this model is also very limited. One limitation was at this point we don't know how to learn these weights. These are W1 to Wn. So then in 1982, or there was another idea in the 70s, but in 1982 basically the first model of learning these weights, that is basically parameters of this neural model, was proposed using the technique called backpropagation. That is, you apply for a given input x1 to xn, you compute its output, basically take the linear combination, and then apply some sort of activation function, let's say the state function here, and then depending upon whether it is matching with the actual output, or basically by looking at the error, you can go back and update these weights. Okay? So this can be some sort of a learning process. But again, the limitations, there are a lot of limitations. One limitation is this kind of model cannot learn very complex tasks, and it's just a single neuron. So that's another issue. So it was later, in 1982, there was another computer scientist, Hoffield, and he proposed this thing called Hoffield nets, okay, where his idea was that you can take several of these neurons models and you can combine them in a network. And then you can learn all these weights, Wn, and for each of these neurons you can have different parameters and you can learn these weights. So this is one picture where there are three. Okay, so basically there are L neurons, U1 number of neurons, and they are finally output of each of these neurons can be thought of as an input for the next neuron. So let's say there are U1 number of neurons, each one of take n size input and outputs one single value. And so if there are U1 number of neurons, then there are U1 number of outputs. You can create another neuron from these U1 values, okay, such that the output of each of these U1 neurons can be thought of as an input for the next neurons. Okay. So this makes this entire structure slightly more complex, and there are several more parameters, and it was not practical. Okay, this was just an idea. Finally, in 1986, these three scientists, one of them is a psychologist and two of them are computer scientists, they gave this multilinear perceptron, that is basically an Hoffield net, along with the backpropagation. So this is now you can see that there are three neurons, at like in the beginning there are 3 neurons. We give the n neurons. Okay. So in the picture there you can see that there are 3 neurons. There are n input size, and we have n number of output. That is, there are n different neurons in the first layer, and then each of these neurons. So you can think of then output of each of these n neurons form another neuron that is basically from 1 to j to n to k. So it's basically you can see that the idea of finite is already applied here, that it's a slightly more complex structure. On top of that, they also propose that here these weights can be learned by the back propagation training. That is back propagation algorithm. That is, we can compare the output of this complex network with the actual output. Let's start with some weight parameters for a given input, x1 to xn. We compute the output, and then we compute the error, that is how far the actual input is from the output. And depending upon the error, we adjust the weights of this network. And again, we recompute the output for the new weights. And we keep improving these weights until the total error is minimum. Okay. So that's basically the main idea. And the key idea here for the back propagation is that you remove the fraction of rate of change of error with respect to weights from each weight. So basically, if you want to update the weight Wi, then you say Wi, the current Wi minus fraction of rate of change of error with respect to each weight. So this way you can. So this is the main idea of back propagation, and this comes from the gradient descent. Okay, so this was very popular, and this work is so important in the field of the current AI/ML that Hinton got Turing Award in 2018 for this work, which is actually equivalent to the Nobel Prize winner in computer science. So then, in the 1986, but that is same time. Another model was proposed, that is recurrent neural network. So in the previous model, we have seen that we have this complex network and all these parameters can be learned by the technique called backpropagation for a given input. But the thing is, for a given one single pass of input, that is one instance of input, the network learned basically network updates these weights just for that particular instance of the input. But in the cases where there are context, for example, in the text, so in the text statement, or in the time series data, where the previous value is important or relevant, this kind of model cannot take care of, cannot learn the pattern in the kind of data. So for this, a new model called recurrent neural network model is proposed, where for the okay, so one more thing I want to tell you here. There are 3 layers of network here. So the first layer is called input layer, then we have a hidden layer, then we have output layer. Okay, so the input layer is all the input dynamic input values are going. Output layer is the output values, and in the hidden layer we basically we captures the output of the so in this network, so from the hidden layer, the output of the hidden layer for the input t minus 1 is passed on to the hidden layer of input t. That is the main idea of recurrent neural network. So this way, when we are training for the input xt, that is the input instance at time t or index t, it also learned the pattern from the input at xt minus. So because of this idea, these network now can be used for the problems where there is a interconnection between, like for example, English sentences or time series data, where there, it is basically time data or some kind of. So when the data are dependent on the previously seen data. So for that kind of problem, this model becomes very popular. Then in the 1989, we have another model, that is a convolution neural network model, where so up to here we have seen that these complex networks were already created, and they can also learn the pattern in the problems where there is a lot of interconnectivity amongst the data, but it still this kind of networks are still not very useful for problems like images. Okay, that is very popular these days. So for images, we have in 1989 we have a model called convolution neural network model. The main idea is inspired from the image processing, where given the input image, we apply some kind of a filter and we compute the convolution of these images. Okay. So this is a popular convolution in the image processing, but the same idea was later applied in the neural network architecture, where for your filter, the filter values are basically learned by the neural network. So that is the main idea. And then you can basically convert this image, you can apply some filtering, and then you can, kind of. So these two processes, the convolution and the filter process together, you can think of it as a feature extraction. Basically, extract the important features from the images. So let's say we are giving images of dogs and cats and animals, then this can basically, this part of the network can learn, what is the, nose or like, some body parts of each of these animals. So it can basically extract the features, and then we can apply the classification. Okay. Basically the main neural network part which we have just discussed. So basically the main idea here is that before we apply instead of applying the neural network directly to these images, we can also apply some kind of we can learn the filters or basically we can extract the features from the images, and then we can apply the network. It's a more, it can predict better. Okay, so I think let me quickly talk about two more things and then we go to the next part. So another two, these are very important in today's context, the generative adversarial network, and then another thing that was in 2014, the main idea of it came in 2014, and then the transformer. Okay, so what you see these days called ChatGPT, so that is G for generative and T for transformer. So what is the generative models? So in the generative network model, we have two networks. Okay, they compete with each other. Okay, a network D and a network G. So let's say we have some real data, let's say some real pictures or some text, and then the G network will generate the random noise or some sort of useless data or wrong things, and then the network D will take both the actual data and the wrongly generated data, from the network G, and then it will discriminate between the real and fake. And in this process, the weights of both D and G are learned. So you can think of that in the end, if we, we train with a lot of data, this kind of network, then this network Z can be extremely powerful. It can actually, in the end, basically it's learning what is the real data, what is the real images, how does the real pictures look like, how does the real text look like from the fake. So that is the main idea of generative, and the transformer main idea is in the simple language, a transformer is based on some attention mechanism. That is basically you learn the context of the the sentences. Let's say in English, originally it was idea was developed for the languages, natural language processing. Later now it's also applied in time series and other kind of data. But the main idea is that you can learn the context of the or some kind of a semantic pattern in the sentences. So that is, I'm not included any picture here for transformer because it's a lot of technical information there. Okay, so far we have seen that this is just a brief history of the neural network or deep learning or ML in general. But why suddenly in the last 7-8 years it's talked about, or why it is very successful now, although we have one of the best models in 1989, but only in the last 5 or 8 years or 10 years there is a lot of talk about this. There are two reasons, and these two pictures explain that. One is digitalization of data. So this particular graph, if you see, that is exponential data growth since 2010. And on the picture on the right, if you see that the deep learning model or these neural network based models can outperform any traditional or most traditional models of like statistics beyond a threshold of the data. So this line you can think of like a threshold. So below this threshold, of course, for several problems, the traditional statistical models will still do better than these neural network models. But beyond this threshold, it has been observed that these deep learning models can basically bypass all these traditional models. And this threshold was passed somewhere around 2009-10. Okay. At the same time, another factor for this success of ML is the computing power. So in the last 20 years, like this particular pink line, you can see that it is 3,000 times decrease in the cost of storage since 2000. So the cost of storage, cost of computing is continuously decreasing, and the processing power is continuously increasing. At the same time, and of course the growth of digital data. So these three factors, because of these three factors, suddenly in the last 10 years, we can see that all these deep learning or neural network models become extremely powerful. Okay, so now in the second part, I will talk about some basic key terminology or key things just to start with, like let's say, the practical side of AI ML, like what all we need. So if you see on the right hand side, it's a complete Python program that can do these 5-6 things. Okay, it can import the correct modules, that is all the computer code it required. It can create a neural network architecture. It can load some very popular data known as NISM data. It can normalize these data. We'll learn some of these things. later, and it can train this architecture on this data, and it can even predict for us, for some small examples. This entire piece of code, it's completely readable. If you look at, we will later see that even you can generate this code. You don't have to even know how to write this code. Okay. This also we'll see later in the demo part. So the main idea is that, like, maybe this was not possible 5 years ago, 10 years ago. It was difficult if somebody wants to use machine learning or data science for their research, or they want to know they want to predict certain things based on machine learning AI models. Then they needed to know programming. They also need to know ML and basically. So without programming, it was not possible 10 years ago, even 5 years ago. But now this is not the case. Even if you are not very comfortable or you have very little knowledge of computer programming, but you want to use these AI ML based tools, you can use them as a tool, okay, for your research or for any kind of, for yourself or any kind of business. So just some key important concepts that will be important if we are basically using this AI as a tool, okay? Because these important ideas are key ideas, and although the more you learn, the better, but at least these things are enough to start with. Okay, so the one key thing is activation function. So you see that in the first picture, I said that you can take a neuron and then the neuron get activated, or some kind of a state function. So those are called activation functions. Okay, when should a neuron get activated, or this kind of decision? So they can be so these are the popular activation functions. If your output is, let's say, between 0 and 1, then you can use sigmoid function. If your output is between -1 and 1, then you can use 10 hyperbolic function. There are also other popular activation functions for rectilinear unit and also linear functions. The other thing you should know is loss functions. Okay, loss function basically compute the error of the final output. When the neural network is learning, it computes the error. So just for the minimal learning, for the regression problem where your output is a continuous, you should use mean square error, and for binary or for classification problem or binary input or more than one input, you can use cross entropy loss. Okay. That is important. Then there is something called batch size and learning rate. When you use a neural network model, you need to specify the what is the batch size, what is the number of epochs, or what is the learning rate. So learning rate is the lower the learning rate, your network will learn slow. If your batch size is higher, then your network can do overfit, okay, but it will be fast. If your batch size is basically how much data in one pass of the training I should use. Okay. So let's say if your data size is 1 million and you specify batch size is 10, then first 10 instances of the data will be used in one learning, then the next 10. We cannot process the entire 1 million data in just one go. That's the idea. And the number of epoch refers to how many times a single input is basically used back and forth in the entire training. Or basically refers to the one complete pass through the entire training data set. Basically, one scan of the entire training data set is called one epoch. Then there are concepts like regularization, where you need to, sometimes it happens that your neural network model is overfit to come up to solve the problem of overfit. One solution is regularization, and one of the technique of regularization is basically randomly dropping some of the neurons. You can just set those weights to those neurons to 0. And yeah, the other thing is normalization. Sometimes your range of your data can be arbitrarily large, okay, or arbitrarily small. So your data, input-output data should be normalized. So the two standard techniques, Z-score normalization, that is you subtract the mean divided by standard deviation, or you can basically map all the data to 0, 1, between 0 and 1. That is a min-max scaling. So you can do the scaling of the data. One more thing, transfer learning. So the transfer learning is very important concept in machine learning. It happens that you already have a trained model, and that is very useful for most of the tasks. But there are certain tasks your trained model is not very useful. So instead of kind of creating a model again, you can use an existing trained model, okay, which is trained for the old data set, and you can retrain it for the new data set. For example, in this case, the model is already trained for the dog, but now your data set can have both dog and cat. So you can basically retrain this existing trained model, okay, for the new task, that is dog and the cat. This is very important because the pre-trained models are very useful. Okay, so now I think it's time for a demo, a quick demo. So as I said in the beginning, the main idea is that you can all use these machine learning based tools for some of your research as well as your other day-to-day tasks, even without knowing the computer programming. So now I will quickly show you some 2 or 3 examples with the popular tool, which is a ChatGPT, that is a generative transformer model. Saraswat? Yeah. Okay. Okay, so you can just, this. If you give this line of instruction, this 6 line of instruction, it can give you a Python code that you can run directly without. This is another example of a demo. I'll share these slides so that you can basically, if you just copy paste this text in the ChatGPT, it can give you a Python code that you can just copy and run it, and it can perform all these tasks. Your Python code can do this task. I wanted to show demo, but I think you already overstood. This is the last example. So in this example, I took 2 years of daily data from for a particular stock for 20 months of data, and I predicted the stock price for 4 months using some time series based ML model. Now compared this predicted price with the actual price, visualize these data into the charts, and your ChatGPT can give you the entire Python program that you can just copy and paste in your, let's say, Google Colab and run it. It's as simple as this. You just go to ChatGPT, give this prompt, the effort prompt, and it will produce the computer program for you, which you can use to create your own model, to train your own model, and to use your own model without knowing computer program. Yeah.
One example you can show.
Sure.
This example you can show.
Sure.
The data file should be in CSV or?
No, I will show you this one example. So let me take this simple example. This one. This is simple example. There is no. In fact, let me take this one also. So I can just go to Google Colab. This is basically collab.research.google.com, where you can run the Python code, and so I can just copy paste this data. So sorry, I need to go to ChatGPT first.
ChatGPT is free.
Yeah.
And ChatGPT Plus is not free.
No. ChatGPT, Gemini, you can also use Google Gemini, any of these, most of these. At least ChatGPT I have tried that this prompt is working. So for example, I can just say this to ChatGPT, that download 2 years of daily data from this, and then do this. And then it will give me this code. And then I can just copy this code here. In fact, there will be comments, so you can, I can just paste this code. In fact, you can read the comments and it is telling you what is happening at each of the steps. In this case, as you were asking, will it read the data from your file? No. So I asked the ChatGPT to download the data from Yahoo Finance. So it's downloading the data from Yahoo Finance for the Reliance stock for the 2-year period. And all the instructions I gave, it's running. So now I can basically run this. Okay, so I think the reason is, I need to install this.
Say if you go wrong somewhere, is there an AI support?
Yeah. So I can do this. I can just copy this error and I can go to ChatGPT. Where is that? It is here. And I can just tell it that I got the following error. Okay, so it gave me the new code. Okay, I can maybe now this time quickly test once more. You can see now the error is slightly later part of the code, but you can again throw back this error to the ChatGPT and say that your code is again giving this error. It will again update the code. So this is one way. I think this was working in order to prompt this error. I think I should, sorry for taking extra time. Any questions?
So because you are running out of time, just to finish the second speaker, then we'll go for the questions.
Okay, thanks.
Thanks, Professor Saraswat. Now I request Kumar to deliver his talk.
Yeah, hi. Hola. So thank you very much for attending the session. And after the lunch, it's very hard to concentrate on a very technical detail. So I'm not going to bore you with a lot of technical. I just show you how we are utilizing AI in real world. And I'm going to talk 3 things. The first, how we are gathering the data, and earlier how we are doing, and now how it's transferred. Then visualization, because that is the one area you guys are working or give you the more sense. And then I'm going to talk about forecasting, like how these things help you, or where we are right now in terms of forecasting. Because GPT you guys have heard a lot, but I think in forecasting we are not at that stage now, but in coming years we definitely. So let's see. So data collection, like broadly, if you see the source of data, right? So major source of data lies on website, documents, or you have a database or a system. Now earlier, how we are doing? We go and like when I started using Hives and all, but now when I turn myself into a ML engineer, lot of thing is done by automation, right? So that is the beauty of using all this stuff. So I will show you some of the things, like how we are processing a document, and I must understand you guys have a lot of information in document and you would love to have this technology so that you can extract information easily, right? So we built one solution called Doc AI, and where you can upload any document, either it is PDF, Word, a laser or an invoice or anything. And if you want to extract any information, either it is present on a table or a textual or a graph, and even you can interpret the graph. So this is the architecture, like you just need to upload the document and the pipelines will extract all the things separately, table in a separate folder, figures in a separate, and title and figure in other. What technology we have used here? The first is the identification and then extraction. So identification in ML, there is a technology called a layout detection. So we first did a layer detection and then we extract the information out from there. This is a one example where you can find a model is detecting properly where the text, where is the image. This is a one example when you have information in table and it's also contain textual information, and this is how you get the tabular data. If you want to extract some information over the website, you do not have to worry about. Earlier what we do is we need to write a scrapper, right? Now you do not need to write even a scrapper. You just need to give the link from where you want to extract. The program will extract the information you want. So this is a one example where I wanted to extract a NAV value, and it's run daily to extract the information. All are automated, right? And even we have a one product called InfoPulse where we are extracting almost 10,000 daily news, and it's done by AI. So if you see the news structure, right, there is a header and there is a body, and then there is a lot of garbage on the page. So how to extract the relevant information is the challenge, and that we do, and we are daily extracting almost more than 10,000 news articles, and then we have also built a smart pipe. This is a tool where you can, even you do not know much about technology, you can connect your DB, you can do all this stuff like say a data analyst is doing, like standardization, outlier detection, correlation, and everything you can find easily. And you can set up the tool very easily. I am not going to show you the demo, I have a very limited time. And now, if you have anything on extraction part, I am happy to take the question, make this conversation more interactive. So, before jumping to visualization, any question on extraction I would like to take. If not, I am continue. So, once we gather the data, the next part is to visualization, right? So, for a visualization, we have a different tech, and mostly if you see the company want to visualize the information in dashboard. So we are expert in Power BI, Tableau. We also work in Salesforce, ClickSense. These are the tools we are using on a daily basis. I would like to just give a 1 minute talk in here. Like, this chart are very much familiar to you guys. Lot of chart you guys are using daily, like line graph. So the first thing we need to understand where to use this. So whenever you have a numerical data and you just wanted to understand the trend, you can happily use this. Bar chart we are using a daily basis. This is the most easiest and the most you can say informative graph we all are using, right? And there is also a radar graph you can build if you want to just see two things in a single graph. These are some samples we have developed or delivered to the client. So when like this is a scatter graph. So when we are using a scatter graph, when you do not have a link between the data and you wanted to just explore data relation in unstructured data. So you can go and happily use this. This will give you some essence, right? And then this is a radar one. So I'm not spending too much time. And here one thing is you all must have heard about 80-20, right? So this is a graph we deliver to our one client. So they have produced almost, they have a 6,000 SKU, and they get a revenue from like 80% of revenue are just generated from 20 of the SKU. So this so like if it's not important how many product you have, it's always important how many product is giving a more profit, right? So this kind of analysis you can do to understand which SKU you have to focus on to get a more revenue, right? So you can build this type of graph. Now the interesting part, I will try to finish in quickly. So I must understand you guys have already using ARIMA, SARIMA models. How many of you have using this type of model, like exponential smoothing you guys are using, right? ARIMA, I guess you guys are also using. Regression, I guess all are using, right? So I have just categorized the all technology in 5 groups, and because that is important, because as we grow, model is also getting powerful, and it's not always important every model is work for every data. So we do not just bypass the previous models or the algorithm we have. We need to just find out the solution where we can utilize both, right? So if you see this statistical model, there are a lot. Even ML model, you can find linear regression, random forest, XGBoost type of model. Deep learning, you must heard RNN, LSTM right now. But there are a lot of other models like NHITS, TS mixture, tide. These are a very powerful model and recently developed. Transformer based, you all are aware of GPT is based on transformer, right? So we are going through in that direction. So like in the recent 1 or like say 3 months, we have seen the 3 powerful model like Time GPT, Tempo, Lag Llama. These are based on large language model. Now here is the one graph which give you a more satisfaction to you guys and more pleasing. Why I am saying so? It's research till 2018, and lower the value, better is the model. Okay. So if you see a statistical model is outperforming all. It's ML or anything. But after 2018, there are a lot of new models which came, and this graph give you some like where we are heading right now. So there is a one term called assemble. So what assemble mean is you have a, like say, not a single model, you have a multiple model and you are combining multiple model to predict one output. So it's not a one. I am just saying that one person is taking a decision on 100% is taking a decision, or it's based on the voting mechanism. Like say if I am taking any decision, like I just adjourn this meeting, then it's not a right choice, right? If I ask everyone to just give your opinion, then based on your opinion, that will be the best output, right? So assemble is one technique. So we are assembling a deep learning model together to give one single output. So when you assemble these large language model, their performance is quite impressive. It's outperform every model. That is what it's seen in this graph. I have put down a 4 graph here. I'm not sure you guys able to view, but let me highlight the first graph. It's a like say if you have a very a limited data set and you wanted to build a model, a statistical or a ML model. So if you have a limited data and if the time span is a low, like say if I just wanted to predict a next day or next week, then it's might your statistic model will be better than AI or a deep neural network. But when you try to predict a longer duration, like say 1 month, like say 2 months, in that case, deep learning model will be best suited or it's outperform all. The next thing I'm talking about is when you increase your data. Okay, so once you have a limited data, then a statistic is good. Now say this situation is you have a huge data set. Then in that case, LM or deep learning model is best suited for you guys. Now the third graph, like say in today's world we are generating a lot of data and all data are mainly unstructured and it's very hard to get a very good linearity or a stable data. So if you have a stable data, it's good you have, then you can just go and apply your statistic. It is a best model to be performed on seasonality, linearity or stability. But if you have a data which contain trends, which have like say other challenges like NaN value and all, your data is not a structured one, then a deep neural network will good fit for you. Now maybe you guys also thinking about how much accurate our model will be after just switching from like say stationary model to deep neural network. So maximum you can get is around 10%, but these experiment conducted in 2018, whatever I'm showing you, but it's almost 3-4 years, and we have developed a very sophisticated model or a weighted model. Now this is the comparison between econometric model or a machine learning model. So fundamentally it's based on a statistic and machine learning based on identifying the patterns. This is the fundamental difference. Second one is statistic model are more explainable. You know why this output is, right? But when I say deep neural network saying this word, the first and the foremost question is how they are doing, how they are saying, right? And the question is, this is a black box. But do not worry, that is also going to be solved in coming year, and there are a lot of research going on explainability, and some of the models like decision based or tree based have those explainability also. Handling features, if you have a very standard data, you can go with the econometric, but if you have a messy data, as I also mentioned, then the best way is to do a machine learning model. So these are some difference. If you guys want, I can discuss some of the use case, or else I can skip this. So let me skip this. I just wanted to highlight ML model is not best for only financial prediction. You can use this model in every aspect of your life. Either it is financial prediction, either it is traffic prediction, either it's predicting any machineries to be fault, or either GDP or anything. It will help you in all aspects of your life, not in any single thing. So the first is we did a one project for a retail client, and they just wanted to forecast their sales value of particular SKU. So this is one, and then we are working with NHI also. So we are trying to predict a volume of a traffic volume. So these are some of the results, and as I mentioned, this model doesn't have any restriction. You can apply anywhere if you have a data. Okay. So now I'm just going to talk for 2 minutes more. So now this graph shows you the curve and where we are right now. So if you see from 2021, and Suneel sir has already discussed about what are the major model have come, but these are the highlighted one is the most important event in the history. So the first one is in 2023 when the people have discovered how to represent the text into a vector. So machine only learn or understand text, numerical data, right? The first thing is to convert whatever you have into a numerical thing. So that is happened in 2013, and the next thing is big event is in 2017 when transformer model came, and that is published by Google, and whatever the model you guys are heard of or seeing of, all are based on transformer right now. So GPT, BART, any large language you are hearing, all are based on transformer architecture. So this is a huge, you can say, a step in the AI/ML. And then in 2022, in December, the world got shocked when ChatGPT released. And I hope you guys have already utilizing it. If not, start utilizing. It's a very powerful tool. It will make your life so easy. But the only thing, whenever utilizing, just give a one quick overview before doing anything, because it's based on generative, right? So there might be some hallucination in that. So next thing is, earlier it's very hard to build a model, right? Earlier it's whenever some new project came, it's almost took 7 months to deploy one project, like data gathering, data cleaning, and then doing a model deployment. It will take easily almost around 7 to 8 months. Now after development of like say GPT or LLM based model, you can do the stuff in hours or a day. So that is the power where we are heading. Now the this slide I am talking about which sector is going to be affected mostly. So we already seeing how GPT is impacting the world, and so the most affected sector will be the financial and fintech, because there are a lot of work which is going to be automated using this a powerful tool. Then consumer based a service, like earlier we need to deploy a person to just answer a question, right? Now you are seeing a lot of chat bot or a bot on lot of website. So any query can be handled or any query can be get answered at the instantly. Healthcare is the next big thing we are going to see in next a few years, and Google is closely working on that, and one paper they have released and they almost predictive, they are almost 80% accurate, but we need to wait for a more like say a few more years in that to be happen, like say 95 or 99% of accurate in that case. Real estate, industrial technology or mobility, like supply chain will be the one that is going to be affected, and natural resource or climate technology will be also affected but not that much. So this is all from my side. If you guys have anything you can ask. So thank you.
Thank you, Mr. Arbind. So we'll take up some of the quick questions because we are running shortage of time.
This is a question to both the speakers. You talked about the importance of mathematics. Say if one wants to understand the loss function of your support vector, random forest, lasso, least absolute shrinkage, then bridge, then ridge, then elastic net, is there a good reference? From teaching point of view, I refer to this book by Econometrics with Machine Learning by Felix Chen and Laszlo Matthias. The first two chapters are brilliant, but they start talking about the properties of these estimators, meaning the ones which we used in traditional econometrics, small and large sample properties. What are those properties? So that way we have to understand the distribution. Right? So these are some issues. For example, in lasso, you minimize the residual sum of squares subject to some penalty function, and that penalty function is regarding the beta norm. So b1 plus b2 if it is equal to 1, and we are told that it will do the shrinkage, because the idea is that you are dealing with 10,000 variables, n is only 25. Traditional econometrics, n minus k will not do, x dash x matrix will not come. So from teaching point of view, we want to understand the mathematics. Okay, coding, you said Google Colab, run the codes, you don't even have to learn. So students want to know that what is this weighing matrix, how is it changed? Sorry, it was a little longer.
Yes. So Suneel sir, if you just wanted to answer the first one about books, because that is not a my area.
Right. So one book which I like in this is a book called Machine Learning Defined by Jeremy Watt. It has all the details and its key focus on the question discussion there about mathematics, and each of the terms is explained with the intuition and with the graph and with the math behind. So machine learning defined by Jeremy, what is one popular book for the specific question you have asked?
Yeah, the thing that when you are looking from the statistical point of view, because teaching are moving from the direction of statistics, so statistical learning books will be much useful in that way. There are few good statistical learning books which will follow that. From the data, so with the small data you are taking and with particularly you just cited with the many such variables. Normally with the statistics, doing so many variables may not be that easy to handle the things. So, over the period of time, the convergence between the statistics and machine learning people has come to the way to see how the statistics they are going to use within the context of machine learning. Where machine learning more powerful point is the big data. Means more data will be there, how it is going to handle. So, how effectively you are going to use the statistics inside the machine learning context, which is basically derived from computer science, that will be much more helpful to explain the students from that perspective, rather than trying to address from the statistical, where it's, if you look at statistics being derived from mathematics, traditionally it is being designed in such a way that they will work on the samples. So, because of the pragmatic reasons those days, reaching out to the people, it was more expensive to collect the samples and so on. So, but in the machine learning era, when it came, the data is available plenty. How will deal with that huge amount of data? So that is the major thing here. So now the convergence is coming up between the statisticians and that of the machine learning professionals. Is that how effective the statistics can be used within when you are taking a sample of that of 1 billion customers are there, when you are trying to take whether 1,000 will be sufficient to build the model or 2,000 will be sufficient to build the model. So that way how, without changing the distribution, original distribution, how you are sampling so that that small data set will be of the same distribution and you can do the experimentation on that.
Hello. My question is not purely related with this data analytics and all, but yesterday when we were in session, we were actually worried a bit about regional disparities and all other aspects. Now today we are talking about this machine learning and all. I agree that generative AI, DHAI, these are the next issues and it will remain to stay in every country. But the question is, in the process, the transformation that is going on, what is the way out for countries which are mostly emerging or which are underdeveloped? Because it is going to create a massive hit in the workforce, that's for sure. In today's presentation also you are telling that some of the sectors like consumer services, whenever we are talking about even your call centers and all, DHA and all these things are taken care. So now at that point of time, what is the way out for us? And how we should we regulate or which we should channelize all these things so that there should be a balance?
Yeah, so every development has some drawback or some opportunity, right? And so before accepting, we need to think about all those things. I'm happy you are worried about that, but as a developing country like India, and where most of the people, if I'm thinking about the statistic, I'm not sure how many people are using this thing, but not more than 15%, I guess so. And when electricity developed or when computer first time came, right? This question or this doubt comes at that time also, right? So it's not always if something new happen in the society will just vanish every opportunity. It will definitely going to benefit you, definitely benefit us, and at the same time it also give you the better opportunity of working, right? And I guess I'm not in that area of researcher, but whatever I read about, it's not going to create the vacuum of the say unemployment. If it's vanish some, it will generate a more. Hope I answered your question.
Yeah, obviously, sir, that's for sure. Just only one thing is actually the speed at which these transformations are taking now. It is not there whenever we are talking about TVs and all. So that's the only whether we are equipped with that speed.
Yeah, so in that case, we need to prepare ourselves to whatever is coming, we need to prepare ourselves. That is the only measure we can take. And the speed which we are going is tremendous. I'm almost 8 years of industry experience. I haven't seen anything like this. If you seen the paper released in last 1 year, it's around 21 times more from the previous. So there is lot of development, not in AI in every aspect, either visual or textual, but we are not that much going forward or speedily in forecasting or a statistic. But I guess that will be going to happen in 1 or 2 years. So we need to prepare ourselves. That is the only thing we can do. That is in our hand. Any more question?
Okay, to add to this also one more point. You see, your your concern is important, no doubt. But reskilling is needed now. We have to reskill ourselves for the new things to come out. Basically, this AI or ML, they are not going to replace where we are good at, particularly the judgment aspects. The judgment side will remain as it is. So we should reskill how to understand AI, where it can be used, where it cannot be used, and how to interpret its outcome, the explainability. All those things are new portfolios are going to come out in future. So we have to reskill for that. Okay, this is already time. We can stop here. Okay, thank you. Thank you very much for the Professor Saraswat taking from basic neural network through deep learning, CNN and recurrent neural network, GAN and ChatGPT. Of course, finally, due to some unfortunate reason, it didn't work, but ChatGPT works in that way. Because every time you will ask some question, it will give different answers. So because it is based on the stochastic nature, so obviously the program it will generate will be different from the program he has tested many times before also. So that is the problem of ChatGPT because it's a learning network. It is nothing that it has remembered something and giving the outcome. So every time it will be different. So thanks Professor Suneel Saraswat for his nice talk and going through from the basics of neural networks till the large language models. And subsequently, Mr. Arbind Kumar, which basically highlighted on how we'll be ensembling even the deep neural network and so, rather than only taking the, like say, random forest where or the traditional model, multi-model things, you can prepare better, efficient models with the help of this ensemble of deep learning and other advanced learning methods are there. And particularly its applications in GenAI and prompt engineering, which is basically the forthcoming things it is coming up, which is going to play a vital role in our development. So thank you, Mr. Arbind. And thank you to the organizations and thank you all to be present here and be attentive for the entire session.